Hello. So today we are going to talk about Agile estimation. We'll talk about the story points, their nature, the advantages, what are the different techniques, just in general, how awesome estimation is in Agile. Let's say if I ask you to size a tennis ball, how are you going to do it? Well, one way of sizing is that you can tell me the volume of a tennis ball. I can tell you that the diameter of a tennis ball is about 2.5 inches. Now, can you size it? I'm sure the wheels in your mind would be turning. You must be trying to recall the formula for the volume of a sphere, which is 4/3 pi r cube. And now you can find the radius by dividing the diameter by 2. You can put in the values in the formula and you'll come out with the 3 point something, approximately 4 cubic inches. This is great. You've given me a good estimate of the size of a tennis ball, which is very measured and calculated. Let's try another technique. If I gave you a golf ball and I asked you, can you tell me the size of a tennis ball compared to the golf ball? Now you can visually see, and from your experience, you can tell me something like the tennis ball is twice as big as a golf ball. And that seems very fine. So technique 1 is the absolute measured calculation by using the formula, putting in the values, and coming out with the exact cubic inches volume of a tennis ball. Technique 2 is a relative measure. You're telling tennis ball is twice as big as a golf ball. Now, let's see which of these two techniques is faster. So clearly, you were able to do a relative measure faster, right? What about precision? As you know, precision is how close the values are to each other. Now, in this case, technique 1 is clearly more precise because you're using the absolute measurement. We also have to take into account the accuracy. And the accuracy, you can tell from this picture here how close we are to the bullseye. Now, which one of these two techniques you think is more accurate? Yes, technique 2 is always going to be more accurate. A relative measure is always more accurate. This room is twice as big as the other room, or half the size of some other room. My living room is twice as big as the master bedroom. That relative sizing is always going to be more accurate. And in Agile, we go for fast and we go for accurate, not for precision. Now, this is great. How does it relate to the actual estimation of tasks and stories in the real development? So let's look at the relative scale. Most of us are familiar with the Fibonacci series that goes as 1, 1, 2, 3, 5, 8, 13, and so on. The next number in the series is the sum of the previous two. That's the whole Fibonacci series. In Agile, we use a modified version of this Fibonacci series that goes as half, 1, 2, 3, 5, 8, 13. And after that, it starts rounding to 20, 40, and 100. This is the modified version of Fibonacci that we use. So this gives you a good relative scale if you have to size your tasks or your stories. In this whole spectrum, on the left-hand side, have 1, 2. Those are simple tasks. They should be trivial. They should be easy if they are sized that way. In the middle, you have the medium complexity tasks, 3, 5, 8. 13 or so. And after that, on the right-hand side of the spectrum, you have the hard and really complex ones. So this gives you a good idea about what is the scale that we can use in such agile estimation when it comes to relative sizing. Now, the question is why are we using Fibonacci? Why not just use any number on a numeric scale instead of using Fibonacci? Now, the most significant advantage that you get by using Fibonacci is that you are able to combine complexity and the effort into the estimate. So if you think that if you assess a story or tasks to be a little bit more complex than 3, instead of giving it a 4, you jump to 5. Why? Because when your complexity increases, it does not always have a linear effect on the effort. There'll be more communication required, more testing, more review, more development, more code reviews, more collaboration, even if the complexity increased by 1 point. That's why you jump to the next value in the Fibonacci. Similarly, if something is more complex than 5, instead of giving it a 6 or a 7, you jump to 8. Okay, that will kind of give you a good, that'll give you a good final size by factoring in the effort and complexity together. Now, in this whole explanation, you can tell that these story points, they are all unitless. There are no units attached to these numbers, right? Tennis ball being double the size of a golf ball, it's just a number of 2. There's no unit attached to that. And this unitless nature of story points gives us a couple of very good advantages, which I'm going to illustrate next. The first one is the self-adjusting nature of story points. Let's say you formed a new team and you're trying to run the first sprint. You're planning the first sprint. How are you going to determine how many story points worth of work can you take in the first sprint? Well, you can do a very smart calculation. Let's say everybody in the team says that they can commit 7 hours to the sprint work every day, and there are 5-member team. You can come out with a formula of 7 hours multiplied by 5 members and 35 points. Let's take 35 points in the sprint one. Just keep in mind the formula here is irrelevant. So in sprint 1, you plan for 35 points, but you actually deliver 28, which is fine because it's your first sprint. Your team may be forming. There'll be some discoveries and revelations that you may have had. Now in sprint 2, you can conduct a retro and you can decide, okay, we can do better. And you decide to adopt 31 points, but you actually deliver 32, which is great because you delivered more than what you adopted in your sprint 2. In sprint 3, you got a little bit more ambitious and you adopted 33 points. Now, on the last day of sprint 3, you ran into a scenario where one of the 5-pointer stories that you thought, after doing about half or 3/4 of a work, you realize that there's more work involved in there. It shouldn't have been a 5-pointer, it should have been 8-pointer. Now, what do you do? There are various ways of handling this, but one of the ways to illustrate the self-adjusting nature is that you let this 5-pointer story slip into the next sprint, which is sprint 4, and take only 28 points of credit instead of 33, because you haven't quite finished that 5-pointer. Even though it is mostly done, you don't want to take credit here. In sprint 4, however, you plan 32 and you deliver 33, where you have taken the 5-point credit that kind of spilled into your sprint 4, where you have done most of the work. So you got that 5-point credit in sprint 4, even though you did not get it in sprint 3. And this is what helps the self-adjustment. Now, if you do an average of sprint 2, 3, and 4, you can discount sprint 1 because it was the first sprint. The average comes out to be about 31. Okay. And you can tell it is not very far from the actuals you had in sprint 2, 3, and 4. You had 32, 28, and 33. And 31 is not too far from that. Now, again, I want to emphasize on this concept of accuracy and precision. Well, there'll be some people who would say, okay, I want to be absolutely precise in what I plan and what I deliver. I don't want any deviation. Well, that's fine. But as you know, in Agile, we want to go for more accuracy. So over time, the average that you take is always going to be more accurate. We don't have to beat ourselves to be precise and accurate. As you plan more sprints, sprints 5, 6, and 3, you'll see that there will be some deviation from this average of 31, and that is fine. It'll be more like ripples on a pond. What we don't want is to have this very disruptive, tsunami kind of a wave where you're doing 50 points in one sprint and 10 points in the next sprint and then 40 points again in the following sprint. You don't want such high variance. So this is what is meant by the self-adjusting nature of story points, where your sprints, there are like little deviations in terms of what actually stories you deliver, but they are close to the velocity, average velocity. Now, there's another advantage of using unitless story points. I think we all agree that velocity is a great metric, right? For us to monitor. Let's say there are two teams, Team Alpha and Team Omega. And I am the evil executive, VP of engineering. I come to Team Alpha and I ask them, what is your velocity? Team Alpha says, our velocity is 35. Great. Now I go to Team Omega and I ask them the same question, what's your velocity? And they say that their velocity is 30. Interesting. Team Omega, I say, you got to pick up your game. You are slacking, it seems. Look at Team Alpha. They're producing 35 points every sprint. You have the same length of the sprint. I don't know why you cannot do better. Now I say that and I walk away. What do you think is the fastest and the easiest way for Team Omega to demonstrate a higher velocity? If you think about it, they can very easily change their reference of story points and bump up the story points. So the 3-pointers become 5-pointers, 5-pointers become 8-pointer, and so on. After a few sprints, I, as an evil executive, I come back again and I ask the same question to Team Alpha. What is your velocity? And they tell me it's 36. That's great. I go to Team Omega, I ask their velocity, and now their velocity has bumped up to 40. That's awesome. Now I'm back to Team Alpha. Dude, what the hell are you doing? You're getting your butt kicked by Team Omega. You gotta, bump it up. Now, you can see the problem here. Very quickly, you can tell that you cannot really compare the velocities of two teams. Even though the velocity of Team Omega has shown to have gone up from velocity of 30 to 40 does not really mean that they are producing more outcome. Now, so this is the advantage, because the story points are unitless. At the executive level or at a higher management level, it discourages comparing two teams using the velocity metric. Velocity metric by itself is great when it looked at for just one individual team, but you cannot really compare two teams using velocity. So we cannot and should not compare teams using velocity metric. That's another very big advantage of story points being unitless. So there you have it. I hope this was useful. Thank you for listening.